We're going to find the critical value, Z, used to test the null hypothesis. I'm going to do two situations. The first situation is when the significance level alpha is 0.01, 1%, and the situation is that it's a left tail test. Now for a left tail test, the Z is the standard normal. It's the bell-shaped curve. 0 is in the middle. The critical value for a left tail test is going to be over here to the left. It's going to be right here. Now this area created here by this critical value is the alpha. So this area equals alpha, which is given as 0.01. Now you can use a table or an app on your phone, or the way I like to do it is just to simply use a graphing calculator. Like if you're in a classroom setting and your teacher doesn't allow you to use your phone, you can use, hopefully they'll let you use this. You go to distributions and you want to go down to where it says inverse norm. So I had to hit second and then this button to get to the distributions, and then inverse norm is the third one down on the list. Now, most calculators you have to tell the area to the left, which is the 0.01, and then the mean and standard deviation, if you have to fill that in, would be 0 and 1. So this is the left area. This is the mean, and 1 is the standard deviation for a standard normal. All right, just plug that in. Plug in the 0.01, comma 0, comma 1, and you get about negative 2.33. That would be the critical value for this situation, left tail test. And you do it to test the null hypothesis. Then you calculate the test statistic based off the sample statistics. And if the test statistic is in the critical region, then you say reject HO, the null hypothesis. If the test statistic is anywhere outside the critical region, then you say fail to reject the null hypothesis. All right, let's look at this second situation over here. We have a significance level again. This is 0.055%. This is for a two-tail test. Now, if you have a two-tail test, then the alpha gets split in half. We want to find this critical value again. They're just the same number, just opposite sign, but this time for a two-tail test, since it's split symmetrically in half, this 5%, 0.05, is going to get split up for these two areas. So this area is alpha over 2, which is half of 5%. That's 2.5%, or 0.025. And the same thing over here. Half of 0.05 would be 0.025. So we can find this value and this value doing the same thing. Do inverse norm with the calculator. Area to the left this time is 0.025. All right, let's go to the calculator and plug that in. Go to distributions, go down to inverse norm, plug in 0.025, and you get negative 1.96. And this is totally symmetrical, so if you did inverse norm of the area to the left here would be 0.975, you would get 1.96. So the critical value for this situation would be 1.96. And again, you're going to take the test statistic and see if it's in the critical region or not. If it's in the critical region, you say reject the null hypothesis. If it's not in the critical region, you say fail to reject the null hypothesis. There you go.